don't even think about skipping this problem because this forms the very foundation of a very important pattern, and that is called the prefix sum. Basically, the problem says that you are given an array and you have to find out the longest sub-array that equals a specific sum. Now, although this problem statement itself is very easy to understand, but trust me, this problem can be asked in so many different ways, but the underlying idea will always remain the same. So what we will do is, we will try to understand the problem and learn the mathematics behind it. It is actually very fun. And then we will find out the efficient solution immediately. So let us see what all of this is about. Hello friends, welcome back to my channel. First of all, let's try to make sure that we are understanding the problem statement correctly. It is actually fairly simple to understand. You are given an array of integers and a value k. You have to return me the longest sub-array length whose sum equals k. So first of all, what is a sub-array? For example, I am given this particular array and this is the value of k. Now, this particular array can have a lot of sub-arrays. For example, 5, 2 is a sub-array, 2, 5, 1 is a sub-array, 2 to 5 is a sub-array. Basically, a sub-array is a contiguous non-empty sequence of all of the elements in the array. Find out the length of the longest sub-array such that the sum equals k, where k is 4 right now. If you check out this array, I have this particular sub-array whose length is 2 and the sum is 4. Once again, I have this particular sub-array whose length is 4 and the sum is also 4. And then I also have one more sub-array with just a single element and the sum is again 4. So you have multiple such sub-arrays, but you have to return me the length of the longest sub-array. So for this particular test case, you need to return 4 as your answer, because this is the length of the longest sub-array. Notice that you have to first find out, okay, how many sub-arrays are possible, and then tell me that, okay, this is the longest length. There can be multiple sub-arrays with the same length. In that case, it's fine, and you can just return any one of the length. But it has to be the maximum. So if you feel that the problem statement is now even more clear, feel free to first try it out. Otherwise, let us dive into the solution and start with the most naive approach. I'll be very honest, when you start to approach this problem, it feels relatively simple. You think that, okay, I will be able to tweak around and find out the longest subarray. But then you start to realize it can be a little tricky. For example, if you're given this array, how do you approach it in the most basic way? Well, what you can do is, you can start to find out every subarray that is possible. So, subarray of length 2, then you will try to find out subarrays of length 3, and then you will try to find out all the bigger subarrays until you find that sum. But soon you will realize that finding up all of these different combinations, it can take up a lot of time, because all these different combinations can overlap as well, correct? You have only one terminating point that, okay, if the sum becomes greater than k, then I have to stop. But overall, doing this process again and again will take up a lot of time. The time complexity in fact becomes order of n squared, and that is certainly not what we desire. What is the biggest bottleneck over here? The biggest bottleneck is that you are trying to compute all of the sums again and again. When you are trying to sum the sub-arrays of larger length, you are again calculating the sum of the smaller sub-arrays also. That is the biggest bottleneck. So somehow we need to solve for it to find an efficient solution. This is where you are introduced to the idea of a prefix sum. Now, what is a prefix sum? A prefix sum is nothing but a running total of all of the elements that you have encountered so far. So when you are at the very beginning, you haven't got any element. So the prefix sum is 0. When you traverse the first element, you found one element, so the sum becomes 5. When you have one more element, you get 5 plus 2, and then the sum becomes 7. Similarly, you can keep on going ahead. For this particular prefix sum, the sum is now 9. If you keep on going ahead, the sum becomes 14. This is where you can keep a running total of all of these prefix sums. But how does it help you? For example, you want to find out the sum of a particular subarray. Let us say I want to find out the sum of this particular subarray. When you were going via the brute force approach, what did you have to do? You were finding out all of the sub-arrays of length 4 and then you calculated the sum of each of these elements, right? But this prefix sum can be very helpful. For example, let me take up two positions. I have a position I and I have a position j. Since I have to find out the sum of this particular sub-array, these are the two positions that I'm taking. Now, try to find out two things. What is the prefix sum until your length I? If you calculate the sum of all of these numbers, you will get 14. And the next thing you want to calculate is the prefix sum until the length j. If you add up all of these elements, what do you get? You will get the sum of 18, correct? Now, try to think. If you have to get the sum of these four elements, can you do a prefix sum at j minus prefix sum at I? Because you have calculated the sum of all of these elements and you have calculated the sum of all of these elements. So if you subtract out all of this, what do you get? You get the sum of this remaining sub-array, correct? So if I subtract both of these values, I will get the sum of this particular sub-array. And as per our problem statement, what do we have to do? If the sum of this sub-array equals the value k, then this is a valid sub-array. So do you think it is safe to say that if I am able to find out this particular condition, if the prefix sum at j minus prefix sum at I, if this value is equal to k, then this is a valid sub-array. Try to think about it again. Let us say I'm not looking at these two positions, but instead I am looking at two new positions now. Let us say prefix sum at I is this and prefix sum at j is this. So what are the two values that you're getting? You are getting a value 9 and you're getting a value 5. So once again, is this condition true? Yes, it means this is a valid sub-array. So this is the idea that we want to take and we can build up our solution on top of it. Before going to the solution, let us also understand the mathematics behind it. It is very interesting. Over here, I have the same array, correct? And now we will try to keep a track of two values, the prefix sum and prefix sum minus k. Let us see what happens to all of these values when I plot a graph. So first of all, I'm starting with the prefix sum. What is the first value that you get? The first value that you get is 5. Next, you get 5 plus 2, that is 7. Then 7 plus 2, it is 9. Then you get 9 plus 5, and that is 14. Then you have 15, 16, 17, 18. And then the last value, it is 4. So 18 plus 4, and that is 22. So this is how you are getting all your prefix sums. Now let us try to plot this other value also, prefix sum minus k. Basically, whatever this value is, you subtract the value of k. So now what you're getting? So for the first value, 5 minus 4, and that is a 1. The next value is 7 minus 4, and that is a 3. Then you get 9 minus 4, and that is a 5. Then 14 minus 4, and then you get a 10. Then all these incremental values. And then the last value, 22 minus 4, and that is a 18. So all of these green dots are the prefix sum, and all of these blue dots, these are the value prefix sum minus k. Now, what are the interesting values over here? Check it out. If you see these two values, both the prefix sum and prefix sum minus k, they are lying on the same x-axis. That means the prefix sum over here was 5 and prefix sum minus k is also 5. What is this telling you? The difference between both of these values is equal to the value k. So what I am getting? I am saying that up till this and up till this, these are my values of I and j. This is giving me a valid sub-array. And yes, the sum is k. Similarly, try to find out any other x-axis where you have 2 points. So you find another 2 points at this particular x-axis. I have these two values. And what are these values corresponding to? It is corresponding to this particular value. This is prefix sum minus k. That is the prefix sum at the previous value. And this is the higher value. So once again, prefix sum at j minus prefix sum at I. This is another sub-array that you're getting. And then this is the last sub-array that you're getting. And this is for the single element. So mathematically, these are all of the separate sub-arrays and these are the lengths also. What is the biggest length? This is the biggest length and it has 4 elements. So mathematically, we are able to prove that, okay, this approach is gonna work for us. Now, let us try to see how you can solve all of this programmatically. By the way, you must have already realized why this problem is so important. It is so brief and yet very, very tricky. And that is what makes it tech companies' favorite. And if you are interested in finding out all of the different problems that are asked by a lot of different tech companies, I have a really valuable resource for you. And that is available in the description below. Feel free to check it out. And now let us go ahead and try to implement the programmatic version of this problem. Over here, I have the same array available and the value of k is 4. What we are going to do is, we are going to keep a track of two particular values, the prefix sum and the prefix sum minus k. We are going to keep on calculating these values as we iterate through our array. Why these two values? If you remember from our mathematical proof, when did we find a subarray? We found a valid subarray when these both values, they were the same. If they are the same, it means I have found out a particular valid subarray. I just need to find out those indexes, correct? So that is exactly what we're gonna do over here. I need to start up somewhere. And I also need to remember that have I seen this sum before? Because that is how I will be able to compare if the prefix sum is matching prefix sum minus k. So I will maintain a map that will store all of these indexes. Where do I start? I am starting at the very first position. That means the current prefix sum is actually 0. And what is the position? The position is minus 1. Because an array actually starts at the 0th index. So what I'm going to add is, in my map, I will say, okay, the sum is 0 and I first saw at a minus 1 index. Now you move ahead. You move ahead at the first pointer. You get the first element 5. So the prefix sum now becomes 5. And what is prefix sum minus k? That will be 5 minus 4 and that is 1. So you are going to check. Have you seen this value before? I haven't seen a sum of 1. It means there is no sub-array that is ending over here. But now I have seen a sum of 5. So I will add this sum and I will add this index also. It is saying that I saw a sum of 5 at the index 0. Just wait a little while and you will understand all of it. You move on to the next index and that is 2. What is the prefix sum now? 5 plus 2 and that is a 7. And prefix sum minus k. So 7 minus 4 and that gives you a 3. Have you seen the value 3 before? No. It means there is no sub-array that ends over here. But I found a new sum, so I'm gonna add it to my prefix sum map. It means I saw the sum of 7 at the index 1. Move on to the next location now. I see the element 2. So the prefix sum now becomes 9. And what is prefix sum minus k? 9 minus 4 and that gives you a 5. This is where things get interesting. Have you seen this sum 5 before? Yes, because it exists in my map. And where did you see it? You saw it at the index 0. So now what did you get? You basically got two prefix sums. This is the first prefix sum and this is the second prefix sum, which you obtained at the index 0 and you are obtaining at the index 2. So this aligns perfectly with what we had discussed in the first place. If prefix sum at j minus prefix sum at I, if this value is equal to k, then I have a valid subarray, correct? That means I have got a potential subarray. And how do you find its length? You take up the current index and subtract this particular index. So you get 2 minus 0 and that is a 2. I will maintain this value over here and we are going to update it if we find an even longer subarray. For now, we are going to keep going ahead. But before that, I'm also going to add that I found a sum of 9 at the index 2. We can now move ahead and I am at the element 5. So 9 plus 5 and that gives me a 14. 14 minus 4 is a 10. Have I seen a 10 before? No. But I need to add 14 over here to my map. Move on to the next location now. I get 14 plus 1 and that is a 15. 15 minus 5 is 10. Have I seen a 10 before? No. So I just need to update my map. Move on to the next location. 15 plus 1, that is a 16. And 16 minus 4 is a 12. Have I seen a 12 before? No. So I will update 16 and I will say, okay, I found it at a position 5. Move on to the next position. I get 16 plus 1 and that is 17. 17 minus 4 is a 13. Have I seen a 13 before? No. So I will just update it. 17 and a 6. Move on to the next position. I get a 1. So I do 17 plus 1 and that is a 18. 18 minus 4 is a 14. Have you seen a 14 before? Yes. It means I have found out another valid subarray. And what is its length? Check this particular index and the index I'm currently at. If you subtract both of these values, you will get your new length. And I get my new length as this particular because the index 3 refers to this position and I'm currently over here. So 7 minus 3, that gives you a 4. 4 is greater than 2. So all I'm going to do is I will update my result max. So far I'm saying that, okay, I have found out a longest subarray of the maximum length 4. Before you move ahead, you also add 18 to your map and you will add the position 7. Similarly, you will now go ahead. You see the element 4. 18 plus 4, that is equal to 22. 22 minus 4 is 18. And have you seen an 18 before? Yes, you found 18 and that was at index 7. To find out the length, you will subtract these two values. So this is currently 8, this is 7. 8 minus 7 equals to 1. It means I have found out another subarray. Yes, this is valid, but its length is 1. So you don't want to update your result max. You have completed your complete traversal and you found out that, okay, this has been the longest subarray that I could found whose sum was equal to 4. Pretty efficient, right? In just one traversal, you were able to find out the solution and you just required an order of n extra space just to match that, okay, have I seen this sum earlier? If yes, that means you found out a valid subarray. And this solution works for negative integers as well. Let me modify the input test case a little bit. Instead of 4, let us say the last number was minus 9. So now let's try to start back from the very last position. I am at this particular index. So what I will do, I go on to the next index and now what is the prefix sum? 18 minus 9 and that gives me a 9. Now what do? Prefix sum minus k. That means 9 minus 4 and that is a 5. Have you seen a 5 earlier? Yes, you saw 5 already at the index 0. What does that mean? It means I found one more valid subarray. And what is its length? This particular index minus 0. So where is that subarray? If you look closely, this is the entire bigger subarray whose sum is 4. If you add up all of these elements, the sum is still 4. And what is the maximum length now? The maximum length is in fact 8. And for this particular problem, the solution now becomes 8. So this solution works for both positive and negative integers. Now, based upon all of this, let us quickly do a dry run of the code. On the left, you have the complete code to implement this solution. And on the right, I have my input sample test case. What is the first thing that you do? First of all, you create both your maps and your result and the prefix sum that you're looking for. Now, you start your iteration. You start a for loop that will iterate over each of the element. For each element, first of all, you add the element to your prefix sum. This is how we are maintaining our prefix sum. And then you check if you find prefix sum minus k in your map. If yes, that means you found a valid subarray and you will try to update your result. And if not, what do? You take up this prefix sum and along with the index, you put it in your map. This way, you will keep on iterating upon all of your elements and at the very end, you will have updated your result which will contain the maximum length subarray and then this is returned as the answer. The time complexity, as you can see, is just order of n because you are only doing a single iteration of the array, and the space complexity is also order of n because in the worst case, you might have to create a map for each of the elements in your array. I hope all of this now gives you a very good idea how this problem can be modified in so many different ways. Instead of asking for a specific sum k, they can also ask, okay, find the sum to be 0. Or they can ask you, okay, what can be the sum such that it is a multiple of a certain number k. So in that case, you will have to do a modulo. But the underlying idea about maintaining a prefix sum and a map, that will still remain the same. That is the core idea based upon which a lot of problems are made out of. So, while going throughout the video, did you face any problems? Or do you have any other innovative methods in mind that can even simplify the problem? Also, you can list down any other similar problem that you found which was able to solve using the same pattern. Just tell me everything in the comment section below. It will become a really good place to have a discussion, and I will be happy to answer any question that you might have. And once again, if you like these kind of videos, all the ways I form these patterns and the way I make up these solutions, please do consider subscribing to my channel and share this video with your friends. This really keeps me motivated and I can make more such videos. Also, a huge shout out to all of the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments and early access to new videos as well. Stay tuned for my upcoming video. Until then, see ya.